Hello folks, in this video tutorial I'm going to demonstrate how to analyze data in SPSS through descriptive means. In other words, I'm going to demonstrate how to do descriptive statistics through SPSS. So I'm going to first of all introduce you to the theoretical aspect of it, because most of you might not be well conversant with most of the concepts in statistics. So let's start with the conceptualization. Now, in this tutorial, I'm going to discuss about the theory aspect of this descriptive statistics, as I've said, as well as the practical aspect of it, and try out some exercises based on the practical application. So, apply statistics, or when you are talking about statistics or analyzing data statistically, we're broadly talking about two aspects, which we refer to as descriptive statistics as well as inferential statistics, or making inferences. So by descriptive, it gives it's a statistical method used to summarize or describe a collection of data or a set of observations. So in this case, the interest is in presenting the important or the basic feature of the data. So in other words, by descriptive statistics, you can be able to produce or present the most basic features of your data. It provides a summary of your data. Then, having done your descriptive statistics, you can then proceed to inferential statistics. It depends on how you design your research study. So if it is where you need to test for hypothesis, and you can proceed to do inferential or to carry out inferential statistics. So through inferential statistics, one can be able to make conclusions from the data that are subject to random variation. Random variation, we're talking about sampling variability, like observational errors and all those type of stuff. Then, based on inferential analysis or inferential statistics, one can be able to make a generalization about the population by studying a sample of the population or make future prediction. For example, if you are carrying out, or if your research study is about testing hypothesis, so through inferential analysis or inferential statistics, you can be able to test your your hypothesis, whether to reject your null hypothesis or whatever. So all those kind of stuff can only be done through inferential or carrying out inferential analysis, inferential statistics. So in summary, descriptive statistics is the simplest form of statistical analysis, and like as I've said, it is used to describe or summarize qualitative and quantitative data collected from the sample of sensors. So that reminds us that your data depends on how you design your research questions or your research questionnaires. So normally it's constituted of both qualitative and quantitative data, or it can be made up of qualitative and quantitative data. So through descriptive statistics, there you can be able to describe the attribute of your study participant. In other words, you can be able to describe fully the demographic structure of your participant. Then you can also, through descriptive statistics, this can be presented graphically so that ordinary men or a layman can be able to visualize your data through by being presented graphically. And this squarely depends on the scale of measurement that has been utilized. So essentially, we got two types of scale measurement, qualitative and quantitative. So I'm going to describe or conceptualize and contextualize these two terms or these two concepts during the course of my explanation. So, given the scale of measurement of your data, as I've said, you've got qualitative, which is qualitative stroke categorical scale. Then you have the quantitative stroke numerical. So, in terms of the qualitative stroke categorical, you have the nominal. So if depends on how your data is. Your data can be nominal in the sense that you are just interested in describing the quality or the type. Example of such data could be gender, or you want to know the color of the hair or the religion, and all those kind of data can be classified as nominal. Then you have ordinal. Ordinal is a set of ordered categories. If your data or the responses are ordered or arranged in categories, then in such a way that the first one can have a value more than the second one, then the second one more than the third one. No, in short, if your responses are in ordered form or in ranks, then you can classify that as an ordinal variable. Then on the side of so these two essentially falls under qualitative stroke category. So it can either be qualitative stroke categorical variable can either be nominal or ordinal. Then the qualitative stroke numerical, you have the continuous variable, which can take any value. Then you have the discrete variable. Discrete variable, these are numbers that these are variables that you can count. For example, if I can give you an example of the number of COVID possible or the number of COVID positive cases. So these are observations that can be counted. You can say 10, 20,000, 20,000, 40,000, something of that nature. The number of students attending a workshop. Those type of observations or cases can be counted. Then continuous variable, as we said, can take any value over some continuous scales, can be presented in decimals. So that is the major difference between continuous and discrete variable. So continuous and discrete variable falls under quantitative stroke numerical variables in terms of measurement. Then under quantitative again, you got interval, that is whereby you can determine the distance between data elements, and you have the ratio, though the distance between the data element can be determined like the interval, but there is no 0 point. So in terms of the interval has no true 0 point, and the ratio has a true 0 point. So that is the major difference. A good example of quantitative interval data of variables could be temperature. The difference between, for example, the difference between 20 degrees and 30 degrees is the same as the difference between 30 and 40. So you cannot be able to determine the difference, unlike the ratio. A ratio, a value of 0 means that the attribute or quality does not exist, of which there is nothing like that in terms of quantitative interval. For example, age, the difference between 20 years and 30 years is the same as the difference between 30 years and 40 years. Someone who is 40 years old is twice as older as someone that is 20 years old. So these are some of the examples of scale of measurement that one could talk about as far as the scale of measurement is concerned, as it relates to qualitative and quantitative data. Then, in terms of the quantitative data, so there are certain things that one is essentially interested in measuring in order to be able to explain or summarize the data. For example, the measure of centrality/location, whereby one needs to determine the mean, the median, and the mode. Or if one is interested in the measure of variability, or which we can call dispersion, and this one is concerned with how far the data point lie from one another. And these are used to compare two sets of data. So you can use measure of variability to compare two sets of data. We can as well be interested in looking at the shape of the distribution, which could be normal. If it is a normal distribution, normally it has a bell shape. Sometimes it could be skewed to the right. We're talking in terms of skewedness now. The skewedness of the distribution, whereby the tail is pointing to the right, then we say it's positively skewed. And if the tail is pointing to the left, it's negatively skewed. And besides that, we can try to look at the shape of the distribution in terms of what we call kurtoises, that is the thickness of the tail, whereby it tends to find out or look for the outliers. So these are the essential features that are very important as far as descriptive data analysis is concerned in SPSS or in any other computerized data analysis software. So, yeah, in my next video tutorial, I'm going to present how to analyze or produce descriptive statistics in SPSS by demonstrating it and by using a practical example. So thanks for watching. That is the end of my video tutorial on the theoretical aspect of descriptive statistics.